Okay, friends. In the question, what given the question, first we have to understood that 100 characters alphanumeric message is transmitting in 2 seconds. That means it is telling that in 2 seconds we are sending 100 characters, and they are using ASCII code. That means one 7-bit code they are using, and followed by the 8-bit they are using for error correction. So which is total 7-bit plus 1 bit for error correction. Total bit is 8-bit we are using. Okay, and next they are asking find a symbol rate for 32 level PAM. So we know what symbol rate is, symbol per second. So for getting symbol rate, I required bit per second by bit per symbol. So bit per second I required first the RB what given here, that per 2 seconds I am sending 100 character, and per character I am using 8 bit. So if I am considering this 100 character by 2 seconds into 8 bit per character, so I am getting 400 bits per second. That means in each second I am sending 400 bits. So now what I am using, 132 level PAM I am using. In 32 level pulse amplitude modulation, what is I am using? There are 32 levels. See, my first level let x1 and my 32 level let x32. So I use 5 bit for 32 level PAM. I require nearly 5 bit for each. So I am using in one level I am using 5 bit. So now what is there? My m equal to 32. So per symbol I am using 5 bit. So my symbol per second or symbol rate is what? RB already I got 400 bit per second, and now I got 32 level PAM I am using. So 5 bit per symbol. So my symbol rate is what? 80 symbols per second. So the option is B. Okay, friend. Now we are going for in this problem that finding probability of error. When we are going probability of error, we use the concept of constellation diagram. When we are going for bandwidth, we use the concept of spectrum. We are doing the spectrum and we are finding the bandwidth. But here what asking, there is giving a 16 array com and asking to find the probability of error where given white noise power spectral density. What we know white noise power spectral density is, white noise is a constant power spectral density of value giving n naught by 2. So from this I can get n naught equal to 1. That means my noise value is 1. And from this constellation diagram, I can say I have to find probability of error. So what I know probability of error? One formula is there, empirical formula is that what Pe equal to 2n into q of root over of d mean square by 2n naught, where n represent the number of decision boundaries. What is this n? N is here the number of decision boundary means what? Here one level is 0.25, one is level is 0.75. So there are two decision boundary. In this place of n, I can write 2. So the value of d mean now I have to find. What is the d mean value? The minimum distance between the two levels. So what is the value here? You can see here 0.25 to 0.75, it is 0.5. Otherwise anything you can take, minus 0.25 to plus 0.25. It is also d mean. I can take 0.5. So now I substitute this value 0.5 square by 2 n naught. N naught already I got 1 as it is a given white power spectral density. So my answer is what now? 2 of q, if I substitute this 0.5 square by 2, so I am getting 2 into q of root over of 0.125, which is my probability of error, and the option is option C. Okay. Okay, generally for detection, what we are using three algorithm. One is optimum receiver algorithm, and again is maximum at posterior algorithm MAP, and another is ML algorithm, which is maximum likelihood algorithm. So in the question what given, use MAP algorithm, which is the wrong statement we have to show, or which is the correct statement, it's asking the correct statement. Okay, so what we are, it's given already a binary channel. In binary channel, what is given already? The sending is x0 and x1 and the receiving is y0 and y1. And x0 already given the probability is 4 by 10 and x1 giving the probability of 6 by 10 and the conditional probability already given p of y0 by x0 is given already y by 5, that, and the p of y1 by x0, what is the meaning? When I am sending as x0, receiving as y1, what is the probability given? 4 by 5. And when here also given, when I am sending x1 getting y0, the probability is given 3 by 5, and whenever I am sending x1 getting y1, is the probability is giving 2 by 5. So I am using now MAP algorithm, maximum at posterior algorithm. What is actually this algorithm? If I have to give y0 is detected as x0 when if my p of y0 by x0 dot px0 is greater than p of y0 by x1 into px1. If I use this and if this condition satisfied, then I consider as y0 is detected as x0. Like this also, y0 is detected as x1 when I am using that p of y0 by x1 into p of x1 is greater than p of y0 by x0 into p of x0. If like this I'll put all the value, then finally after putting all, substituting all things, I got the answer what? Y0 is detected as x1, it is the satisfying statement, and y1 is detected as x0, it is also the satisfying statement, which is in option 3 and 4. So as per question, whatever given in option B is the both third and fourth are correct. So answer is option B. Friends, in this question what given, one input we are giving to meshed filter whose transfer function is h of t and h of t given meshed filter, and input I am giving s of t, I am getting y output y of t. What asking? The output signal of amplitude spectrum of the output signal asking in the question. So what I am giving input now, e of minus mod t. It's given in question only input is e to the power minus mod of t. So what is actually I know meshed filter? Meshed filter transfer function I know h of t equal to s of tb minus t. So now what I know, y of t equal to s of t convolution of h of t. So in place of h of t, I can write s of tb minus t. So if I am taking Fourier transform of this, what I am getting, y of f, s of t I am getting s of f, and convolution in time domain is multiplication in frequency domain. That means in Fourier transform. So and here shifting in time domain is exponential multiplication in frequency domain. So what I will get now, y of f equal to s of f dot s of f e to the power minus j 2 pi f tb. Tb is the shifting value. And what I am getting for amplitude spectrum I required, amplitude spectrum is what, yf I am taking, this phase part I remove, so it is s of f square, and what is the input given, s of t equal to e to the power minus mod t. So for spectrum I have to take the Fourier transform. What I know in Fourier transform, if I am getting e of at in input given at mod, what is my Fourier transform, 2a by a square plus omega square. This is what I got here, e to the power minus at, a is 1 given, so 2.1 by 1 plus omega square. So now what my y of f equal to I got 2 by 1 plus omega square, and as I got already y of f magnitude is s of f square, so 2 by 1 plus omega square by which equal to 4 by 1 plus omega square whole square. So as per question what I got, 4 by 1 plus omega square whole square, it is given in option B. Okay friends, what given in the question, one 7-4 block code given and parity bit given as using some formula, and asking what the mathematical relation also given for parity bit, asking to find the generator matrix. Okay, whatever given here, 7-4 block code given. So I know from 7-4 block code n equal to 7 and k equal to 4, number of parity bit what, n minus k, number of parity bit which is n minus k, which equal 7 minus 4 equal to 3. So now, what is the expression given for parity? How to find parity? P0 first given D0 XOR D1 XOR D2, and P1 given D1 XOR D3, and P2 given D0 XOR D2 XOR D3. So I know what code word equal to data word into generator matrix, and C equal to, which equal to C equal to D into G. But asking here what? Find the generator matrix. What I know generator matrix? Generator matrix in the format I k cross k, P k cross n minus k. K is what here I got already 4. So there is the identity matrix of 4 cross 4, and the parity matrix is of 4 cross 3. So identity matrix I taken 1 0 0 0 1 0 0 0 0 1 0 0 0 0 1. I taken this, and using this formula what given P0 equal to D0 XOR D1 XOR D2, D0 XOR D1 XOR D2. What I got P0 1 XOR 0 XOR 0 I got 1, and again P1 what given D1 XOR D3, D1 what given here P1 I am finding now. So D1 XOR D3, 0 XOR 0 I got 0, and again P2 what given D0 XOR D2 XOR D3, D0 1 given D2 D3. So 1 XOR 0 XOR 0 is 1. Like this I'll do here. Again the second thing I'll do here also the same relationship I will follow. Then I got the parity matrix like this. So this is my generator matrix, this is identity matrix, and this is parity matrix got, and the total matrix I told generator matrix. So then generator matrix is what? This one what given in option? Its answer is option given in D option it is.